Adding and subtracting fractions. One rule, you should already know this, but you must have a common denominator, always. Must have a common denominator, right? Because the common denominator makes it so you can count the same size pieces. If you think about an easy example, you've got a half plus a fourth, right? You can't just add straight across. What would you get? You would get 2/6, you would get a third. That's not the actual amount. Like, picture this in a pizza, right? Half a pizza plus a quarter of a pizza. You put those together, what do you have? You have 3/4. So your answer should be 3/4. So somehow we have to take this, 1/2 plus a fourth, and get to 3/4 as the answer. The way you're going to do it is you're going to make a common denominator. Let me rewrite this. And that's basically just going to cut your pieces into the same size piece. So this 1/2, right, you're going to turn it into 2/4. And then if you're looking at the picture, 1/2 is 2/4. And now you can count the pieces, 1, 2, 3/4. So that's why you need the common denominator, okay? All right, so let's just practice a few here. First, let's look at mixed numbers and talk about your options for that. So let's say the example was 2 2/3 plus 1 3/4. Now you have a choice. You could keep them as mixed numbers, or you could make them improper and add from there. The only thing is then you probably have to change it back into a mixed. So I usually like to just leave them as mixed numbers. I'm going to look at the denominators, the 3 and the 4, and try to come up with a common denominator. This is really least common multiple, which we just did. So it's looking like 12. Now we have to complete the puzzle here. 3 times what gave me 12? 4. So 2 times 4, that's going to be 8. Over here, different puzzle. 4 times what gives you 12? 3. So 3 times 3, 9. Now we add the whole numbers together. 2 and 1 is 3. 8 and 9 is 17. Ooh, bummer. We have an improper fraction right here. We have to turn this guy. It's thinking, here's its thought bubble, 17/12. It's thinking, really, I'm 1 5/12, right? 12 goes into 17 once with 5 left over, so 17/12 is really 1 5/12. So you're going to take that 1 and add it on. So your final answer is really 4 5/12. Okay? All right, so that's adding, and that's nothing, that's the craziest thing that could happen with adding. You could get an improper, but then you just add it on there. With subtracting, things can get a little crazier. So let's look at 5 1/3 minus 3 5/6. Okay, so if I start the same way and I keep these as mixed numbers, so I'm going to have a 6 on the bottom. This one's going to stay. 3 times 2 gave me 6, so 1 times 2 is 2. Now, zoom out of this problem here. Look at what you've got. 5 minus 3 is going to be fine, but 2 minus 5 is not. That's going to start to give you a negative, and in this case, it's not going to work out, because look, you've got 5 in some stuff, minus 3 in some stuff. That should give you a positive amount. So what you're going to have to do is, I call it borrowing. You're going to have to borrow from this whole number. So you're going to knock it down to a 4. Now you're borrowing one whole from here, and you're going to add it on to the fraction part. So you're adding one whole, but you're going to be clever about it. you're going to really add, since this denominator is a 6, you're really going to add 6 over 6, because that's equal to 1. And you're being clever by making it the same denominator. So now this 2 is really going to be an 8, because you're adding 6/6 to 2/6, and now it's 8/6. So really, you're always going to add over, if you borrow, whatever that denominator is. That's how it's going to work out. Then you can do the math. 4 minus 3 is 1. 8 minus 5 is 3. Reduce if possible. And there you go. Now, if you hated that borrowing, you can avoid it all the time, because you could just make them improper. So let's say you got to that step, 5 and 2, 6, minus 3 and 5, 6, and you're like, oh no, that's going to be a borrowing one. I hate borrowing. I always get it wrong. You can avoid it by making these improper. So as a review, to make this improper, you would do 5 times 6 is 30. 30 plus 2 is 32. Keep the denominator. 3 times 6 is 18. 18 plus the 5 is 23. And then you can subtract. 32 minus 23, that's 9. And there's going to be your same answer. Okay, so you can avoid the borrowing if you want to. Okay? All right, hopefully that makes sense. Now, there's another thing you're going to have to deal with, and that's if there's negatives. Because negative fractions do exist, so we do have to deal with them. So let me show you an example here. Oh, we have 2, 3. So if it was 1 and 14/15 minus 2 1/3. First of all, zoom out. Look at what you've got here. 1 in some stuff minus 2 in some stuff. That's going to give you a negative answer, right? So you kind of have to see the big picture here. If you start doing the math, you get a common denominator. Make it 15, so 3 times 5 is 15. 1 times 5 is 5. What would you do if the fractions weren't there? 1 minus 2. You would really, in your head, be doing this minus this and know you get a negative answer. So kind of in my head, that's what I'm going to do. I'm going to do the 2 and 5/15 minus the 1 and 14/15 in my head, which means I have to borrow. I'm going to add 15 to the top, so that's 20. I'm getting 6/15, but I have to remember it was going to be negative. Man, that can be confusing. Divided by 3. So you really have to understand the integer rules to understand what's going on here. Again, if that's super confusing to you, I would suggest once you get here, you get the common denominator, make it improper. I think you'll see it better that way. So let's do it. If I made this line improper, so 1 times 15 is 15, plus the 14 is 29, minus 2 times 15 is 30, 30 plus 5 is 35. Right? You see 29 minus 35, you could do keep, change if you want. How do you do 29 plus a negative 35? The signs are different, so you really subtract them. You get a 6, you remember it's got to be negative, so there's your same answer. That might be the way to go, making it improper. There's really less steps to remember. All right, try one here. See if you can figure this out. Try 8 and 3/5 minus 11 1/2. So very similar to this one. All right, pause it and see if you can get this one. All right, so first I would make common denominators. 8 and 6/10 minus 11 and 5/10. Now I could either do this business, switch it around and subtract it, or you know what, I'm going to go the improper route. So 8 times 10 is 80, plus 6 is 86. 11 times 10 is 110, plus 5 is 115. Yeah, this is easier for me. 86 minus 115. Or in other words, 86 plus a negative 115. Maybe do that on the side if you have to. Right, that's 9. 229. And it's a negative. So negative 29 over 10. 10 goes into 29 twice. That gets you up to 20 with 9 left over. And there is your answer. All right. Try one more. Yeah, try one more. Let's see here. Number 5. 6.5 minus 9 3/8. Go ahead and pause it and see how you do. Did you pause it? Okay, so this is 6 4/8 minus 9 3/8. I'm going to make them improper. 6 times 8 is 48. That's 52. 9 times 8 is 72. 3, 4, 5, 75. So I'm doing 52 plus a negative 75. That's going to give me a negative 23 over 8. 8 fits into 23 twice with 7 left over. There you go. How'd you do? Good. Okay, and the final twist, here it is, for the accelerated math class, is we have to deal with variables. This is kind of fun. So we'll just do some examples. You'll see what I mean. So one example might be like this: 15 over x minus 8 over x. Well, you already have a common denominator of x, so you might as well just keep it. Keep the x. And then you just have to do 15 minus 8. 15 minus 8 is 7, and you would be done. That's all you can do on that one. So if it's already a common denominator, fine, nothing new there. All right, let's try one without a common denominator. So how about 10 over x plus 3/4? Man, what would your common denominator be for 4 and x? I mean, I guess you'd have to just stick them together, right? 4x. So your common denominator would be 4x. Now, let's do the puzzle here. X times what gets you 4x? Well, times 4. So 10 times 4, this would be 40. Over here, 4 times what gives you 4x? I guess times x. 3 times x, 3x. You add these together. I mean, can you put 40 and 3x together? No, so I guess your answer would just be this. 40 plus the 3x all over 4x. And that's all you could do. Okay, try one like that and subtracting. Let's say it was 12 over y minus 6 over 7. All right, try to get your common denominator. You can pause it and try it. All right, so the common denominator would be 7y. So y times what gives you 7y? 7. So 12 times 7, 84. 7 times what gives you 7y? I guess times y. So this would be 6y. Same thing. You can't really put together the 84 and the 6y, so you're going to leave it. And that's as simple as you can get it. All right, try one more just to see if you're getting it. We'll be good to go. So 9 over 10 plus 3x over 5. Give that one a try. So I'm going to keep the 9 over 10. Make that 6x. I guess I'm just going to get 9 plus 6x over 10. All right. Good job, guys.